Day 25. Okay, that's tomorrow. Today is Wednesday, so this will be the video for tomorrow. Let's get to it. Move things around. Marker, pen. Equation expressions. Okay, this is your second part, right? Charles has 12 pieces of pizza. He eats P pizza. Write expressions represent how many pieces he has left. So this is very, again, very simple. This is how much he had. He eats P, and that would be the expression. Okay, to represent how many he has left. Okay, P could be whatever, 5, 6, 7, 8, depends how many he ate. You have 5 blue sweatshirts and X gray, so you have 5 blue plus X gray shirts, we don't know what, so here is to find the total number of sweatshirts that you have, it's the 5 that you know already, plus whatever number X is. Aaron makes $9 an hour. He worked 8 hours yesterday. Write an expression to represent how much money he made. Well, to find out how much money he made, you would take the $9 and you multiply it by the hours that he worked. And that would give you your total. Carrie has this many dolls, M dolls. Your sister has 10 more dolls than Carrie. So whatever Carrie has plus 10, that's going to be how many my sister has. Okay. So if Carrie has 5, my sister has that 5 plus 10, which would be 15. You have 60 pieces of candy. You plan to share the candy equally amongst F friends. So you have 60 total friends, 60 total candies, and you divide it among your friends. And if you divide among your friends, 2 friends, that means everybody gets 30 candies. Each of your 2 friends gets 30 each. If you have 5 friends, that means everybody gets 12, so forth and so forth. So depending on the number of friends, the amount of candy they each get will vary. $3.50 is the price per gallon for 1 gallon of gas, which is, thank God it's $2.50 now. Write an expression to represent how much money Sam spent. Well, it's going to be the price per gallon times the number of gas, or how much gas is times G, right? 2 gallons would be $7, 3 gallons would be $10.50, and so on and so on. Okay. The high temperature yesterday was 80. Use the equation below to determine the temperature. Okay, so this is one of the equations that we have done in class. So we know that it's 80 degrees Fahrenheit. So 80 degrees Fahrenheit to anybody in the rest of the world would mean very super, super hot. But so let's translate that to Celsius. So C equals 5 over 9. Parentheses, I'm going to change the F. I'm going to put 80 minus 32. So inside the parentheses, so C equals 5 over 9, and inside the parentheses, 80 minus 32 is 18 goes 1, 7, 48. Really? 8, 10 minus 2 is 8, 7 minus 3 is 48. Ugh, what a negative number. So inside the parentheses is going to be 48, so I can remove the parentheses and just leave it like this. So 5 over 9 times 48, or I'm going to put this over 1. So multiply the top and then multiply the bottom. So the bottom I get 9, and then top 5 times 48. 48 times 5 is 5 times 5 is 0. Carry the 4, right? 40, 20, 24, 240 over 9. So the Celsius temperature is 240 over 9. Or better yet, I'm going to actually divide that out and see what an actual value. Divided by 9, it's going to be, let's see, 2 times 18. 6 left over. Now I go to 60. How many times? 7? No, 6. 7, 6, which is 54. 6 left over. Add a 0. Add a decimal. And it looks like it's going to be 26.66666. So let's just round it to 26.67 if we go 2 decimal places. Okay. So there's a temperature, which sounds about right. 26 degrees. 26.67 degrees Celsius equals to about 80 degrees Fahrenheit. Yeah, that's right. How many adults were in the theater? Okay, so let's see. Each adult member. The total amount of ticket the situations represent. Okay, 9x plus 2x equals 880. How many adults were in the theater? How many? There's something wrong here. Each adult movie purchased is $9 per ticket. Right? And Okay, and $2 per soda. Okay, the number. Okay, and all right. So it's going to be. It's obviously an equation, right? So the first thing, or what you have to do before this, 9x and 2x can be combined. Instead of saying 9x and 2x, 9x plus 2x is 11x, right? Equals 880. So I would have combined these two first because they're like terms. Now I solve this as I solve all the equations that we've done. So that says 11 times x, so this is a multiplication equation. So the opposite is division. So I'm going to divide this side and this side by what? By 11. So by 11. This 11 becomes 1. So that leaves me with just 1x, so just simply x. 880 divided by 11. Okay, so we're going to divide 880 by 11. And that's going to give us 80. Okay. And that's our answer, x equals 80. So let's go back here to our equation and just say, and see if it works out. So I'm going to check. So it would be 9 times 80 plus 2 times 80 equals 880. I don't know if that's true. 9 times 80 is 720. 2 times 80 is 160, and that is indeed 880 because this added together gives me 880. So I know my answer is right. So as far as my answer, as far as answering the question, how many adults in this were in the theater? Well, it was 80 adults. Okay. James makes $7 per hour at his job. T's the total. So if he worked 4 hours and 54 hours, if he made $45.50, how many hours did he work? Well, okay, so here's my equation. T equals 7h. T represents the total. So this 45.50 is going to be entered here. That's going to be our total. So $45.50 equals 7 times the number of hours. So $7 times the number of hours that he works will give you $45. So we need to find out how many hours did he work to make $45.50, right? So again, this is a multiplication equation, right? That says 45.50 equals 7h. So divide this by 7. No, divide this by 7. These two 7 become 1, or just 1h, or just h. On the other side, I'm going to divide $45.50 divided by 7. And that's going to give us 6.5. So he works 6.5 hours. Okay. D equals R times T. We've seen this a couple times in class. Emily drove 55 miles per hour for 6 hours. Use the equation to determine how far she drove. So D is distance, to find out how much she drove. So she drove, to find out distance, what was her speed? 55 miles, the rate, right? And how many hours did she go at 55 hours? 55 miles. 6 hours. So the total distance D is this. 6 times 5 is 30. And she drove a total distance of 330 miles. Alright, so I used that formula and I substituted the given values that were given to me. Carla makes braces. She sells small braces for $3. And the big braces, $5. She sold 10 small braces, right? So she sold 10 small braces. Which one's a small bracelet? The X or the Y? Large braces. It's a small ones. So over here, 3 times, and here, that's replaced by 10 because I know, right? Small braces are 10 plus 5y equals 65. 3 times 10 is 30, plus 5y equals 65, right? I multiply this. Now, remember when we did, the first time when we started equation, I showed you a scale, and we took something from, and I took some of the books, and there was a puppy. So if I took this out, I must take from this side. So here's your scale. On one side, you have 30, and the other side, you have 65. So let me remove 30 out. If I take 30 out, right? I'm going to take 30 out here. I'm going to do minus 30. And this is going to be a 0, and I'm going to bring down 5y. 65 minus 30 is 35. Okay. So I removed the constants first. Okay. Now I still don't know what y is because eventually I want my equation to look like this. So who's the next number I have to get rid of? I have to get rid of the 5. How do I get rid of the 5? Well, it's multiplication, right? That says 5 times. I'm going to divide this by something. And I'm going to divide 35 by something. Divide that by 5, right? 5 divided by 5 is 1, which is 1y, which is y. And here I'm going to divide by 5 again. 35 divided by 5 is 7. There's my answer. Y equals 7. Okay, so let's see if that's true. You get 3 times x plus 5 times y equals 65. Let's see if that's true. Well, this was given to me in the beginning of the problem. That's 10, right? So I get 3 times 10. 5 times y, and y I just found out is 7 equals 65. So let's see if it's true. 3 times 10 is 30. 5 times 7 is 35, and that's 65. Okay. Again, this one, the coefficients are not coefficient. The variables are the same. One's 4k and 3k. There's no reason why I can combine these two and make it 7k, right? Make the equation shorter. So 7 times a number I don't know equals 84. Can I find out what that number is? Oh yeah, one of the ways of doing that is to use inverse operations. So I'm going to divide both sides by the coefficient. I'm going to divide this by 7. I'm going to divide this by 7. These two become 1. 7 divided by 7 is 1, so I get 1k, or just k. And 84 divided by 7, I believe, is 12. Okay. And does that work? Well, if you go to your original equation, you get 4k plus 3k, so 4 times 12. I know k is 12, right? So I'm replacing the k with 12. 4 times 12 plus 3 times 12 equals 84. Is that true? 4 times 12 is 48. 3 times 12 is 36. Does that equal 84? Yeah, it does. Yeah, 6 plus 8 is 14. Carry the 1. Yeah, 84 equals 84. Okay. You're selling cupcakes for $2 and whole cakes for $10. You need to make at least $50 to make back the money you spent to make dessert. Wine equality. Ooh. Okay. Okay, so this one is we haven't done this in class, and it's okay. So we'll do it. So here's how I would write this: $2 for every what? 2 times the cupcakes, right? $2 times every cupcake plus $10 for every what? For every whole cake, and I'm gonna use W. So if I add the 2 times my cupcakes plus the $10 times every whole cake that I said, I need that total to be what compared to 50? I need that total to be greater than 50 or equal to 50. And that would be my inequality. So based on that, I'm going to use this. So if I sell 5 cupcakes, how many whole cakes would I need to make this inequality true? Well, let's substitute. So this 5 here would go here, so it would be 2 times 5 plus 10W greater or equal to 50. 2 times 5 is 10 plus 10W greater or equal to 50, right? So now I need to, let me just write this. I think it's very hard to see. 10 plus 10W greater or equal to 50, right? So I'm going to get rid of the first. So I'm going to solve this as an equation, okay? So I'm going to be minus 10 over here, minus 10 over here, right? So let me put a line in the middle. These two go out, and I have 10W left, greater or equal, and 50 minus 10 is 40. I divide both sides now, right? This is a division, so divide both sides by 10. And my W is going to be greater or equal to 4. All right. And that's my answer. So if I sell 10 cupcakes, I need to sell how many whole cakes? 4. Okay. You know what? I'm going to skip this, and I'm actually going to do this with you in class. Okay, because I don't think. You know what? I'll do it here too. But I'll also pick up some of these questions in class. So Arturo wants to buy some new shoes. Each pair of shoes costs $40. So $40. And I'm writing P for pair. Okay, $40 times every pair of shoes, and he has to pay for shipping. And shipping is $5 plus $5 for shipping. And all that has to be, he wants to get as many pairs as possible and no more than $100. So whatever he's buying, the relationship is has to be less than 100 or even equal to 100. And so here is your inequality. 40p plus 5 less or equal to 200. So inequality, although we didn't do this in class, we solve this in the same way you would solve an equation. Left side and right side. And obviously the difference is that this is an inequality. So here you would go like this. What's the number you want to get rid of first? Well, you want p, right, all by itself. You want to isolate this. You want to get rid of the 5, you want to get rid of 4, but you get rid of the 5 first, right? So you do that minus 5 here, minus 5 here, and that's 95. 100 minus 5 is 95. This 5 and that 5 crosses out, becoming a 0, and I have 40p left. So over here, now I have 40p less or equal to 95. Again, treat it like an equation, okay, when you're solving it. Here's the middle line. I'm going to divide this side and this side. So p is all by itself. So p less than or equal to something. Divide that by 40. And divide that by 40 on the right side. So 40 divided by 40 on this side is just 1 p or just p. And 95 divided by 40, okay, it's going to be 2.375. That makes no sense. All right, so 2.375. Okay, so number of pair of shoes, he can buy 2.375 pair of shoes before he goes over 100, right? So can you buy 2.375 pair of shoes? No. So the maximum number of pair of shoes that he can buy is 2. Okay, so we're not going to go above 2. So although this is the answer to this inequality, the number of pair of shoes that he can buy, obviously, because there's no such thing as 2.375 pair of shoes, is 2. And if you put 2 over here, you'll see that it will make that inequality true. 40 times 2 is 80, plus 5 is 85. Okay, is that less or equal to 100? Yes. Okay. I'll do one more. I'll do these two. Okay. So 5, Benny's working 2 jobs. He makes $8 an hour, first job, and $10 an hour, second. He wants to make at least. All right, so the inequality would be $8 times the number of hours plus $10 times the number of hours, and he wants to make at least $200. So at least $200 he wants to make greater than 200 or equal than 200. So in the first job is 8 times the number of hours. The second job is 10 times the number of hours. So 8h and 10h. So let me just write it like this. Maybe it's less confusing. 8h and 10h has to be greater than 200. I can combine these two, right? They're both like terms, so it gets 18h greater or equal to 200. Right? So I'm not going to combine, actually. Let me take that back. I'm not going to combine because that's not what the question is saying. So this is my expression in the first job. This is job number 1. This is job number 2. But job number 1, 8 hours, $8 for every hour. Job number 2, $10 for every hour. And if you add whatever he makes in the first for the second, he wants it to be greater or equal to 200. Okay. So in the first job, he works 20 hours. So how much does he have to work in the second job to be greater or equal to 100? So here we go. 8 times 20, right? In the first job, times 10 plus 10h equals or equal to 200. 8 times 20 is 160 plus 10h greater or equal to 200, right? So now I'm ready. I'm going to treat this like an equation, right? So 160, I'm going to subtract 160 here, subtract 160 here. These two go out because it's just 0. So I'm left over with 10h greater or equal to 200 minus 160 is 40. Right? So now I'm going to divide both sides, right? Because it's multiplication. 10 times h equals greater is greater or equal to 40. So if I divide this by 10, I divide this by 10, that becomes 1. H is greater or equal to 4. So in this second job, he has to work at least 4 hours. So that his total amount of money comes out to be 200. It makes sense because 8 times 20 is 160 for his first job, right? So in his second job, he already has 160. So if he works 4 hours only, 4 times 10 is 40. And 160 plus 40 does equal the 200 that he wants. Now shopping, blah, 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 for supplies. And it has $30 to spend, so it doesn't have any more than 30. Notebooks cost $2 per notebook. And binders, 4 times binder. And this has to be less than 30. So many notebooks and then as many binders, it all has to be less than 30. So if he picks 6 binders, how many notebooks can he buy? So 2n, and here with the b I'm going to replace it. So he bought 6 binders, right? Less than 30. 4 times 6 is 24, so he spent $24 in binders. So 2n plus 24 is less than 30, right? So if you think about it, he doesn't have $30 anymore because he spent 24, so I have to subtract, right? So here, I'm going to go like this. And take away minus 24 here, minus 24 here, right? So this two becomes 0, so 2n is left over. 30 minus 24 is 6. And you can now tell that I'm going to divide this by 2, and divide this by 2, and n has to be less than 3. So the number of notebooks he's going to buy has to be less than 3. Otherwise, he's not going to have enough money. So he can buy 2, 1, or 0 notebooks, but not 3. That was a long one. Complete the table above. 1 CD is 14. Does anybody know what CD is? 2, 3 times 14 is always times 14. 42, is it 14? No, 14. 5 times 14 is 7. So I completed a table. All right, which is the independent variable? This is the independent, right? Okay, so the total cost depends on the CDs that you buy. So this is my dependent. Okay. The independent is the one that's changing and it's affecting the total cost. Okay. Write an equation to help you determine how much you would spend if you bought X CD. So he wants an equation from that. So I forgot the numbers. Let me write this down. So this was 28. This was 42, 56, and 70, something like that. So the total that I spend depends on what? The number of CDs, right? So what's the relationship here? Times 14, times 14, times 14, times 14, times 14, right? So it would be 14, right, dollars times the number of CDs. Let's call it, I guess they're calling it X. The total that I spend equals $14 times the number of CDs. So there's my equation. How much would you spend if you bought 25 CDs? Well, it would be the total equals $14 times 25 CDs, and that is a lot of money. And $350 in CDs. Wow. Your total is $350. Buy CDs anymore? No. Write an equation to determine how many songs you would have if you bought C number of CDs. Right? Each CD has 12 songs. Okay. Write an equation to determine how many songs he would have if he bought C numbers of CDs. So here's the equation. The total number of songs represented by T, the total number of songs would be, well, I know there's 12 songs in each CD, just letter C. So 1 CD, 12 times 1, 12 songs. If I put 2 CDs, so buy 2 CDs would be 12 times 2, 24 songs. How many songs would you have if you bought 9 CDs? Well, the total number of songs I would have would be 12 songs times 9 CDs, or 108 songs. Okay. And I think that's it. And we're up to date.